My name's Deborah Kurata. Here are some links. That's the link to the slides. I've got all sorts of information on my YouTube about not only signals, thank you so much, not only signals, but, and this, is it on? I think this one isn't mine, and mine is the one that's connected there. My YouTube has got stuff on signals and also on standalone components, so if you're interested in more information on that, the code for this talk is on my GitHub that you can get there. All right, so we're going to start with a little code. Very complicated code. Let's see if we can figure out what this means. So we've got x equal to 5, y equal to 3, z equal x plus y. What is z? I have degrees in math and physics, but not arithmetic, so who can help me with this? 8, yes, thank you. Someone's got some math skills back there. Yes, of course it's 8, and you're like, what does this have to do with anything at all? What if we do this and change x to 10? Now what is z? Yeah, it's still 8, because when a value is first assigned, the expression is evaluated at that point, and that's the value. Z does not react to changes in x and y. But in our Angular applications, we want reactivity. So as my little side hustle, I sell Star Wars vehicles. So if you go up to my website, just kidding. So if you go up and you change the quantity, we want it to automatically respond. We want it to react and to recalculate the extended price and the subtotal and our taxes. If we click delete, we want it to correctly react and recalculate our values. So what if we did that instead? Instead of x is equal to 5, x equals signal of 5. Instead of y equals 3, y equals signal of 3. And then here we're going to have a computed, which is associated with the x and the y. It's going to have a dependency on them. Then if we originally log it, we get 8. If we set 10 into the signal, we then get our 13. We have then got reactive code. And we didn't need to use a subject and behavior subject in order to accomplish it. So, signals provide a new way for our code to tell our templates and our other code that our data has changed. It makes our code then more reactive. We can accomplish fancier things with our UIs with less code. And it also improves change detection, as we saw in the keynote this morning. Signals are a new feature available in developer preview with Angular v16, which is the one that came out last month. So we can try them, we can use them now. They work, they're there. And we're going to see some code here in just a few minutes. So what is a signal exactly? Well, you can think of a signal as a value with a change notification. Where can we put signals? Well, we can put them in our components, we can put them in directives, services, we can put them in our templates, especially reading them, and basically anywhere else that we would want to write some code. When we think about regular variables, you can think of that value as just sitting on a shelf somewhere. So x equals 5, we're just throwing 5 onto a shelf, and any of the code can read that value. When we think of a signal, we can think of a box. So we're actually putting the value into the box. The box then lights up to let everyone know that that value has changed. It went from undefined to 5. To read the value, we use parentheses and open the box in order to get the value out. So that's how I remember. That's the little words I say in my head every time I reading a signal. It's like, open the box, to help me remember that I need to have those parentheses on there. So we create a signal by using the signal constructor function. We then optionally can define a type, number, string, array, object, whatever, very similar to how we do HTTP GET. It is optional though, and in this case we really wouldn't use it because it can infer the type from the one. And we do need to provide a required initial value because the signal should always have a value when you read it. Here are some examples. So here would be how we would create a signal of 1. We don't need the type on there. Here we could create a signal that is an array of numbers. Don't need the type on there either. Here we might have a signal that is an object. And so here we might want to define the type so it's clear that those elements are in the shape of a vehicle. Also in this case, we're setting the default to an empty array, so we would want to define its type as an array of vehicle. A signal created with the signal constructor function is writable, so we can put new values into it. We read a signal by using the signal name and the empty parentheses, basically, again, opening the box. Here are some examples. Here in our constructor, we're reading our signal in our code, and then here we're reading it in a template. We can also do something like this, where we're reading the signal object, and then we're dotting into its properties. So we're doing the name and the price there, binding it in our template. So as I've said, reading a signal opens the box to get the current value. Technically speaking, it's calling its getter function, and that's why we have the parentheses on there. And it always reads the current value of the signals. The other thing that reading a signal does is it registers the signal as a dependency. So as soon as we read it, we're basically subscribed to it and we will get its change notifications. So by simply reading it, we're going to get notified of its changes. We don't have to have a formal subscribe like we do with observables. During template rendering, reading a signal, of course, returns the signal value and it registers it in the template. So then if the signal changes, the portion of the view is re-rendered. Now, this feature is not currently available in the preview that we have, but if we want to get the improved template rendering, we can still use onPush. And onPush works with our signals in the current version that we have. As I've mentioned, when we use the signal creation function, we can update or mutate the signal. So we do that with the set keyword, so we can set a value in there. If we want to update the value using the value itself, we would use an update instead, because then it gives us what the current signal is, so we can modify it. So we can times 2, 2 for the price of 1 or whatever. We can also use mutate, which will mutate the item in place. So this is for modifying properties of an object that's in a signal or elements of an array that's in a signal. So we can use the mutate for that. So those are the 3 ways to modify a signal. Setting or updating a signal replaces the value in the box. So unlike an observable that emits values, a signal only has a single value in its box. It also then notifies any consumers that the signal changed, and it uses a scheduling technique for that. So again, it's not like observables where it emits and you can receive these emissions. Rather, it just notifies it that it's been changed. The consumers then update when it's their turn to execute. And by consumers here, I mean any code that's interested in getting those notifications when the signal changed. And how, again, do they subscribe to these notifications? Simply by reading the signal. So as soon as you've read the signal, you're saying, hey, not only do I want the current value, but I want to be notified when it's changed. So I have a little example here that I wanted to talk through to make sure it's clear how this is different than an observable. So in this code, I'm setting the quantity of signal 3 times. Now you might look at this and go, why would I ever write code like that? Well, you could think if you have some complex business logic, you might have some ifs in here. If this and that and the other thing, then we're going to multiply it by 2. If something else, we're going to do something else with that signal. So you can imagine a single method that would modify your signal potentially multiple times. And each time it says, hey, the quantity changed, hey, the quantity changed, hey, the quantity changed. But it's sort of like talking to your teenager. Anyone have teenagers? Just because it said, you say to them, hey, take out the trash, hey, take out the trash. But they're only going to do it once, right? And so when we go to actually see if the trash has been taken out, they only did it that one time, and in this case, we're going to get 42. And I guess the trash metaphor probably shouldn't be used with this, sorry. But you get the idea here. This isn't, again, like observables. You're not going to get every emission. You're going to get, when you read it, you get the most recent value. And it only reads it when it's been scheduled to be running that piece of code, or when change detection in this case is run. You can also define a computed signal, and this is where the real power of reactivity is. Here I'm using the computed creation function, defining a computation function, and it will read dependent signals. So in this case, it's reading the vehicle out of the vehicle signal, getting its price, multiplying it times the quantity, the value that's in the quantity signal. Okay, so computed basically creates a new signal based on other signals. That's kind of what allows us to have some reactivity. An important point, though, is that a computed signal is read-only. And that makes sense, right? Because if it's computing based on some kind of value, you can't suddenly just throw a 17 in there and have it know how to deal with that, because it wants to be computed based on these values. The value is recomputed, obviously, when one or more of its dependent signals change. But it's also important to note that that won't happen until the value is read. So if I have this signal defined in a service, but I don't currently have any component or template that's reading this signal, it will not keep recalculating this. It will only recalculate it when that signal is read. And then once it's read and there's someone interested in it, then every time it changes, it will get notified. Is that making sense how that works? Okay, excellent. All right, the other thing is that a computed value is memoized. That basically means it stores the computed result. So here in this template, I'm using it extended price twice, in an ng-if and in a binding. So the first time it's used, it will perform the calculation. The second time, it's going to reuse that calculation. It will just continue to give you back that calculated value until it changes. So if it's kind of a complex calculation, it won't keep redoing the calculation. There is also an effect for side effects. So here we have the effect creation function, and then some kind of function that executes when the dependent signals change. So we can use the effect by calling it like this in a method, or it can be called declaratively by assigning it to something. All right, an effect obviously should not change the value in the box, or you could potentially infinite loop. The effect function is scheduled to run when one or more of its dependent signals is changed, and scheduled is kind of the key word there. Again, it doesn't stop everything and run your effect. It will finish running your current code and schedule that to run next when it's its turn. So let's talk through an example. So here I've got a list of users on the left, and I am able to pick a user. Whichever user I pick is shown in blue. On the right are the tasks for that user, and I can display then whatever users I pick, I can display their tasks. So let's talk first about the code for the user list component. So we're only going to look at the left-hand side, getting that list and ensuring that one is turned blue. So what would that code look like using signals and observables? Well, here would be my user service. So I'm using the inject keyword, which is somewhat new feature in Angular. So I'm using that to inject my dependencies instead of using the constructor function for dependency injection. Then I have my URL. I'm creating my observable just like I would normally, HTTP GET, and I'm getting an array of users back. Now I left off the error handling just so it fit on the slides. There then are my signals. So in the keynote this morning, they mentioned that there is interop available, and one of the interop features is toSignal. toSignal will take your observable, in this case the users, take its emitted item and put that in a signal. And the really, really cool part about that is that it automatically subscribes and unsubscribes then to that signal for us, which is like the coolest thing ever, yeah? Yeah. Thank you. So in that respect, it sort of works like an async pipe, only we can have it in our code. By default, it provides an initial value of undefined. So if you want to deal with undefined in your template, you can. But in my case, I didn't want to, so I gave it an initial value of an empty array. That way, my user's signal is a signal of user array, not a signal of user array or undefined. Make sense? Okay, the other signal I have down there is the selected user ID. I have it initially starting at 0, which in my code is supposed to mean none selected. I could instead have had undefined in there. Then I have code to set that ID into that signal in this method, setSelectedUserID. So that is what's going to keep track of who the selected user is. In my component then, I again inject the service, or use inject to inject the dependencies, which is the service, and here are my signals. Now, I could have my template talk directly to my signals and my service, but personally, I like my template to talk to my component. Not have to have the template know about the service. So I'm just referencing the two signals out of the service in the component. And then down at the bottom, I've got onSelected, which is the method that calls then the method in the service to set that user. Then in my template, I am using my signals, again, by opening the box with my parentheses. So let user of users, that's displaying that whole list of users. And then I have ng-class, and I'm using the selected user ID signal to ensure it is going to keep the right entry red, showing me which user is selected. Are we good with that? Okay. So going back to the example, that was the left side. Now we're going to talk about the right side. Now we want to get the tasks for the user. So whichever user is selected on the left, we're getting their tasks, which means we're going to need a parameterized URL, right? Because we're going to need to get the tasks for a particular user. Here we want to react to the selected user for those tasks, and we want to react based on the completed status for our title there, because it says 11 completed. When I click on one of those blue buttons, I want it to change to 12 completed, 15 or 13 completed, I can't count either, and so on up there. Okay, so what would that code look like? Starting again with the service, we're injecting what we need. Notice we have a parameterized constructor here. So what we could use, toObservable, is another part of the interoperability with RxJS. What that does is that every time that signal is changed, it will create an observable for us, automatically subscribe to it for us. Why would we want to do toObservable? Because we want to get that ID and pipe it through a switch map. so that we can go retrieve the data. So every time that our selected user changes, we're piping it through, we're getting the user ID. The toObservable automatically subscribes to that new observable that it's creating. Switch map, as a higher order mapping operator, will automatically subscribe to its inner observable. And we can get our to-dos and notice that we have our parameter there. So very slick, easy, clean way to do this. Then, because we want our user interface to be bound to our user signal, to all of our signals, we do toSignal to take that tasks, to take the user tasks and put them into a signal. And at the bottom, we have our mark complete, which is mutating the user tasks to mark that particular task as complete. However, it doesn't work. Okay, so don't take a picture of this code because it doesn't work. Okay, this won't work. Why won't it work? Because toSignal creates a read-only signal. So if we use toSignal to get our data from an observable into a signal, we can't do anything with it. We can't update it. We can only display it. Well, we can't. It's not we can't do anything with it. We can display it, but we can't make any changes to it at all. So we'll just write code now that doesn't do any modifications. That sound like, no, just kidding. So what is an option instead? Well, as of right now, the best option to deal with this, there's a lot of discussion as whether this is the best choice, but one option to deal with this is to create our own signal. So we have our own writable user task signal. Then we use an effect and have it react to that selected user ID. So in our effect, we're just issuing an HTTP GET, and we have our URL there, including that ID. Every time that ID changes, it will cause that GET to re-execute. The big downside of this is we have to manage our subscriptions ourselves, so we have to subscribe, which means we also have to unsubscribe. Okay, and I'm not showing that part here, but you can use one of those unsubscribe tricks, like one of those take, or the new take, I've forgotten what that one's called. Take until destroyed, thank you. And then inside the subscribe, we set the signal, and it's setting our user signal created with the signal constructor function, so it is then writable. So then our code down here works. Okay, and we're hoping that as signals continue to have more features added to them over time, that there'll be improvements to all of this boilerplate that we have to get this to work. Okay, so our component then uses that user signal. We also use computed to calculate our completed count. So we read our user task signal, we filter it to only the completed tasks and use .length to count how many there are. So that gives us 11 completed. And then we have another computed, which is our page title, that uses the completed count computed signal. And that's how we get our title up there. And here in our template, we're reading our signals up at the top there, and also our user tasks. All right, so we should continue to use event handlers for our user actions. So that's still considered a best practice. What do I mean by that? Notice our click event there, we're still using our events. So our click event is calling mark completed. Our click event would call update user selected ID and so on. So that's the suggestion, is to continue to use our event handlers for user actions. Use a signal or a computed for any state or data that could change. You don't need to use them for things that are static, like page titles, unless that page title will change based on the data. Put shared signals or signals that you want to encapsulate in services. Continue to use observables for async operations. So this is not going to replace RxJS on our observables and our observable pipelines. The only thing it may replace is if you're using subject and behavior subject for the sole purpose of having that reactivity, then you don't necessarily need to do that anymore. You can use computed instead. Consider not using signals in framework agnostic code, and by that I mean code that you might want to use in other situations like JavaScript, or straight JavaScript, because signals are part of Angular, and you don't want it in that kind of code. And with that, these are again the links. I want to thank you all very much. Thank you.